Shall we start? Yep, start. Good. So now it's 15:50. So we start the TAPS session. So I welcome to TAPS session. If somebody can close the door behind, that would be really helpful. Yeah. So again, welcome to TAPS session in IETF 102 Montreal. So this is not well. The first thing first. I think most of you know about it. If you don't know about it, you newcomer, please read about it. It talks about your following the process and IETF process and policies and contributions. How should you do? So my name is Jahidur Sharkar, and here we have Aaron, the co-chair. Hi, Aaron.
Hello.
Hello. Thank you. So here's the agenda. I can see here. So we have chairs update, and then we'll have a discussion about what would be the publication track for some of our drafts that we have adopted. Then we have this Troy 3 kind of drafts that is very popular among the TAPS right now. So architecture draft, it will be presented by Tommy. Then there is an interface draft that will be presented by Brian. And then there's implementation draft that will be presented by Anna. And after that, we'll have this experience. So we have some implementers implementing TAPS. We'll listen from them. We have Tommy from Apple. We'll talk about the thing that they're shipping in a beta. We have Tom from Neat Project will present his experience. And we have Tessa to talk about the policy for supplementals from an implementation point of view. And last but not the least, we have this security protocol survey. So Christopher will not be presenting. It will be Kyle will be presenting. Am I right? Yeah. So I think note taker, just make it. Yeah. Okay. Anybody want to say anything about? You want to bash this agenda? It's fine. Good. We're good. Go ahead. Okay. I saw some nodding, so I'll go ahead. So document status, we have not published an RFC since last meeting, but we have one in working group last call, this the main set. And then we have 4 updated documents that we'll know in today's presentation, what is it about. On the milestones, I think we have a milestone that's due, July 2018, the submit informational document defining a security-related transport service. I think that's due that I think, Aaron, we need to move it forward a bit. Yeah.
Let's see how the discussion goes.
Yeah. But the other one is on track. And then we have we have other 2 in 2019. We'll see about it. With that, I think we'll go back to the agenda. And we have this. We should start the discussion about draft publication, track selection. And Aaron, you want to?
Yeah, I'll do it from over here.
Okay.
Bring up the slides. So we had some discussion on the list about we've got the 3.
How do I do that?
Let's see, get out of full screen, go back to here, control click on the slides.
So,
Yeah. Okay, should click.
control click didn't work. No. Well, that'll work.
Full screen, and then the fit to do the fit to again. There you go. Okay. I only have 3 slides. So we had some discussion. We've got these 3 fundamental drafts. Right, we've got the architecture, the interface, and implementation. And so we had a little bit of dialogue on what track should they go on. I think the only one where there's really some potential for doing standardization is the one that defines the interface. I think basically Zayed and I were unable to agree on our own, so we weren't able to propose a decision to the group. So we want a little bit of feedback from you guys, which is probably the right thing to do, anyways. A little bit of sort of process context for this. There's a web page from the ISG on making a distinction between informational and experimental. Turns out this question has come up before. And I've elided most of the text here and tried to just capture the high order bits. Experimental is really about a research and development effort. Could apply to this, right? We're doing some new stuff here, but you could also say that, you know, it's getting a lot of engineering. We're doing some implementation. So informational does not represent internet community consensus or recommendation. That really kind of stuck out to me and seemed odd. I feel like I've seen informational documents that don't fit in that. So, okay, so thanks. ISG, thank you for that. Spencer may pipe up and have something. Oh, he's already, here he comes to the microphone. Wait, Spencer, let me finish my second slide and then you can have your say. So,
You want to have this? Aaron?
What?
You want to have him open it now?
No, actually, I want to do the next slide because that's really just part of this. I tried to collect the information I could find quickly on that applied to this, and so the web page goes on to have some more detailed guidelines, and they've got these sort of 5 tests, and the idea is one of these fits you, then stop, and you don't need to continue because some of them, you know, will take you in a different direction. So if it can't be practiced, it's informational. Well, I think that clearly applies to the architecture document. Right. So to me, that means the architecture document is informational. I feel pretty good about that. 2, if it's not going to be changed no matter what, it's informational. And this is for vendor protocols, other SDOs, stuff that gets published. So that doesn't really apply to us. 3, similar case that could be practiced was developed by the IETF and has been dropped for some reason, but is being published for the record. Well, I don't think that applies to this. 4, the IETF may publish something based on this, on our standards track. Once we know how well it works, it's experimental. So I think if we're in a situation where you were not, if you know you want to publish as a standard at some point in the future, but you're pretty sure you don't want to do it now, experimental is the way to go. And I think that's really kind of the core of where Zahid and I are having our disagreement. And then 5, if document contains implicit or explicit success failure criteria, it also is experimental. So we don't have any explicit success criteria, but I think if we were going to publish this as experimental, we would need to make some, so we would know when it would go from experimental to standards track. Okay, so at this point, let's put Spencer on and see what he has to say.
You can try to speak.
We can't hear you, Spencer. Perhaps you're muted.
Oh, okay.
Can hear you now.
Yeah, I was just not exactly sure where I would pop up on my screen here, showing me that I was talking. So now that I'm talking, the ISG was also somewhat surprised to discover the does not represent the consensus of the IETF part of the definition. So congratulations, you have all qualified for that part of the audition for the ISG. Having said that, and that's actually what I just pushed the button for that. Aaron, you mentioned the thing about, although this is getting a lot of engineering, and I don't want to express an opinion about that until the working group has a chance to cogitate about all of this, but I noticed that when you said it.
Okay. Kyle?
Kyle Rose, Akamai. So the one thing that I don't see on this that surprises me is any mention of the word normative, right? And so
This is just for differentiating between informational and experimental.
well, no,
This isn't for differentiating between those two and standards track. And so I think if it's normative, it would be standards track.
well, not necessarily, right? I mean, there's plenty of normative language in experimental drafts, right? Witness
It
like
should-
TCP crypt.
Okay.
Right. It's basically just saying, you know, if you are going to implement this, you must whatever, right? Informational drafts, right, seem to be something that's describing the state of the. Okay.
What was that, Miriam?
Miria said
Come to the
that you can
microphone. I think
also
this
have
is an
normative
important point.
language in informational drafts.
There shouldn't be?
It can be. It can be.
Okay.
They're asking.
Okay.
I'm
Did you have more, Kyle?
No.
Okay. I neglected, I didn't really put my cards on the table here, which I feel like I should because I want to get feedback on them, right?
Yes,
I think
please do.
I think this should be standards track. I think that there's a lot of thought that's going into this. I think we've got multiple people working on implementations of it. I think that we don't know whether it will be popular and get deployed, but I don't think my interpretation of experimental is where like we're not sure if it's safe, we're not sure if it's going to scale. You know, we've got concerns about the health of the internet or security or one of these sort of concerns that the IETF applies, and I don't think that really is apply to this case. So for me, I think that it should be standards checked. Now, the counter argument to argue with myself is the IETF usually doesn't standardize APIs. Yeah, go ahead.
No, that's not
No.
true.
Sorry, I missed the beginning, and I just saw the other slide you put up very quickly, right? And I want to clarify something, just to make sure that you're having the right discussion. Can you put the other slide up? This one. An informational document does not present internet community consensus. It actually is, it doesn't have to present. Usually most of the informational documents we publish does have IETF
Yeah,
consensus.
I think,
right?
Spencer, I think alluded to that,
Okay,
that we
sorry.
think this may
Yeah,
be
I
an
was-
error. That's okay.
Wait, are you,
I'm
hold
done.
on, were you done with your
Yeah.
thing? Yeah, so I really don't want to have the RFC++ BOF in here again, even though this would have been an appropriately sized room for it. I think that there's, so yeah, this really, because I was talking to Saad last night actually, and he almost had me convinced it's experimental, and I'm sorry, man, but not quite there, right? Like, so I think this is the difference between, or the original intention of the difference between draft and internet standard, or proposed and oh yeah, sorry, right, we got rid of draft, right, proposed and internet standard, right? So, I think we should sort of like, home and move on after we've talked about it a little bit. I don't want to take the whole day on this.
Yeah.
But
Actually,
I am trying to figure out, like, I think we would have to actually write down success or failure criteria for an experiment. And I've been trying to think about those, and I can't come up with ones that aren't like contrived as an exercise to get someone on the ISG to check off a box that says it has success and failure criteria, right? I can't think of real ones.
Yeah, thank you. I think your point about not spending too much time on this is a good one. So let's try to get the input out here quickly, and especially if you are a contrarian view, please be sure to mention that.
Corey Fairhurst, I'm not sure whether. Oh yes, I can be contrary. Okay, so I don't see an experiment. I see personally that we chartered this work to do work in this space, and we're trying to end up with something that we can standardize, just as we do in any other IETF group. We haven't previously done much API work, but we have done APIs more recently in the IETF, so I believe we can do APIs. We've never standardized other people's APIs here. That's a difference, but this isn't someone else's API, so I think it should be proposed standard. I wonder whether the architecture document could also perhaps be proposed standard for a different reason, because other standards groups regards proposed standards as documents which are normative for them. So if we are defining a framework and we want another standards group to adopt this and use this, then there could be some reason for making that proposed standard.
Is there any normative language in the architecture document? No. Tommy's shaking his head no.
There is not, because we wrote it this way. And this is why the man behind was editing in this way. I just leave that as a thing for the end of the process, though, because I think the first thing is to decide on the interface, and I say the interface should be proposed standard.
Okay. Thank you.
Tommy Pauly, Apple. This is a loud mic.
Spencer's a long way away.
Yes. Hi, Spencer.
Michael's even farther.
So I agree with it being proposed standard. I think based on the definitions here, even if the informational one is slightly not correct, I don't think informational really applies for the interface, because if it were not a proposed standard, it would definitely be on something that we would not be sure about that we want to eventually become proposed standard. So I think experimental to standard is the spectrum upon which it lies. And I agree that the experimental aspect doesn't really fit if we need a criteria to evaluate it against. I think it does challenge us if we are writing it as a proposed standard to make sure that we do not include any elements in this interface draft which make it experimental. Because I think there's a gray area there, and we can definitely have extensions to this or peel off experimental parts of the interface that we're not sure about that have not been battle tested in real deployments at scale. And I think that's a perfectly okay thing to do. And the practice of making the interface appropriate to be a standard, I think, will be a good editorial focus for us.
Carl Rose Akamai. Yeah, I mean, I think either experimental or proposed standard makes sense for this, depending on the level of confidence that we have that this thing is fully baked. I'm sort of uncomfortable with moving something to proposed standard immediately when it's still very young and hasn't been, I mean, it's been widely deployed within one enterprise. I'd be curious to see.
It won't be so young when we're done with it.
Well, yes, the standards process does have that property.
And I mean, I'm actually being totally serious. I'm okay with us sitting on a finished document for a while and getting some deployment experience and then revising it before we push it out to an RFC.
Yeah, and
I mean,
I
that may
think,
be the right thing to do.
So if we're going to take that approach, then I think proposed standard makes perfect sense. The other thing is that to the interface question, to the API question, it's fairly abstract, right? We're not creating a C API, right? We'll leave that to POSIX or people who work.
I think
in
the
that
truism
area.
that we don't standardize
Yes.
APIs really applies to those kind of APIs.
So, okay.
Thank you. Colin?
Hi, Colin Perkins. I think I'm mostly agreeing with everyone else, so I will be brief. I think this should be a proposed standard. If we were to be experimental, I think the experiment would be that there is something we are not sure is implementable. And the experiment would be to check if it was implementable.
I don't think you can. Well, I think you can go to PS without an implementation. I think in this case,
of course,
I wouldn't.
but in this case, I
mean,
don't
you
think
could
we
go to
should,
you could go to draft without an implementation.
Well, I think there's a difference between without an implementation and we are unsure if it is implementable.
How else would you be sure?
Well, there may be things where we haven't implemented it, but we can see exactly how to do it. And there may be things where we are unsure if it will actually work in practice. And in that latter case, I think that might be a case for an experiment, although preferably we would just wait and implement it. But if we don't believe that's possible in short time frame.
Yeah, I'm not in a hurry. I'd rather get it right. Zahid.
Jahid, as an individual here. Yeah. So the thing that I want to emphasize here is like this, the thing you said is like experimental part. I mean, I have been involved in API definition, and it may be my failure, but I have never been succeeded to write an API that looks same before I ship something. It goes through an evolution, and I always get it like semi-right, so to say, and then evolve, you understand, you use it. And that's why I don't believe like the interface document need to be like really perfect in the first time. What you can do, we can write and we can put our best effort to make it like usable, because the point here is like if somebody implements TAPS, interpretable TAPS, it doesn't make sense to me, because we're making something for the developers that they're going to use it. So if they're going to use it and they think like this is good, or they have a chance to come back and say like, okay, hey, I used it, but it didn't really it didn't help me much, or it was really good. So we need to make the space for them to actually come back and say what they think about it. Now, that's my essence. Whether we're going to achieve it by putting it as an experimental so that they have something stable, they can try and they can come back, and we can also take the next. I'm pretty sure we can, if we think about it hard, we can actually come up with some experimental criteria, because this is an interface. This is a selection. We have a policies. We can see lots of criteria that actually fulfills one interface. So I can see like there is a way of creating some criteria to do the experimental. So you can do that way, or we can say like what you did. Like we can stay a so long time so that we can make sure we have some inputs from the developers so that these interfaces are useful and usable.
I think Zahid, we're all on the same page, and publishing an experimental RFC and then going back and publishing a standards track RFC is kind of a heavyweight approach to do what is essentially the same thing, which is to wait for a while, get some implementation experience, and then decide that we're ready to go forward. So, yeah. Sorry, I interrupted you. Did you have anything
No,
else?
no, I said like we have done it before. I think this is not the first time that we will see like something that's experimental and then propose a standard. But with that said, if the working group thinks like we can actually keep to our promise here, like we'll be really watchful before proposing to ISG to put something. I want to see that there is a measurable value here using these interfaces that we can say like we're proud of. I want to have it as a standard. But that's what the TAPS will make value. Otherwise, it is an academic exercise to me.
I agree. I also want to point out that I think the point that Colin made about this is the fact that this is such an abstract interface, that a lot of the fine tuning that I think you were referring to is when you do the implementation of the abstract interface, and that's going to definitely take some time, and that doesn't appear in our documentation. So I think it's happened sort of outside of the.
Yeah, sorry, Mayor, just to respond to that one, Jahed again, as an individual. So yeah, I mean, I think we'll like evolve the architecture. Architecture is a really good start, but it will evolve, and then it will reflect on your interfaces and stuff like that. So we'll do that. We'll refine it. So yeah, so we need to be watchful and very caring about doing these things.
Okay. So I'm going to cut the line, and then we'll do some hums, and then we can move on to the technical substance. Go ahead, Mary.
Mia Kulevin, I don't want to state an opinion, just clarify some stuff. So first of all, proposed standard doesn't have to be perfect. There are many proposed standards that have errata, that get updated, obsolete, whatever. Internet standard has a very different notion. It has to be kind of perfect, and they're still not, right? But there are clear criteria. But proposed standard doesn't have to be perfect. The reason why we have experimental in many cases is because we have protocols that we have developed, and we have done some kind of control testing, lab testing, whatever. But we still have issues where we need like kind of internet scale deployment and to test out those issues, and we are not sure if those issues are strong enough to make the whole protocol fail. So I don't think that's the case here. The other point I wanted to make is that if you have the architecture as informational and the interface as proposed standard, then you will have a downref.
Only if it's a normative reference.
Why it's not a normative reference?
There's no normative language in it.
So I mean, like, first of all,
You cut the line, right?
I cut the line. So that's a good point.
I can ask for my SharePoint.
Wrong microphone.
So, Jahed, now just a clarification. I mean, I actually am not sure like this, and what you said, like this wide deployment of TAPS will not hamper something. I don't think like I'm not sure about it because it is actually. So what we're doing here, like we have some standard protocols, right? And the people have been using it in a certain way. We're telling them this is a new interface. You use it, you're supposed to get the best out of the protocols, right? And that actually creates an expectation for the developers who will use it. And then perhaps if somebody was using their protocol on the test, like for example TCP, they got some other protocol, uses it has a different kind of behavior, different kind of congestion control, it's gonna hurt them a bit. So it would be like, I mean, how do you TAPS architecture or TAPS interfaces provides a robust behavior? I think I'm not sure about that yet because we have not gone through that process yet.
But I mean, actually, it doesn't. Like, what happens if it's not robust, right? Like, what happens if I implement TAPS version 1 and you implement TAPS version 2? It doesn't matter. So.
Well, it will matter, right? Because you will get different kind of protocols.
No, because the protocol is the same underneath. We can still talk to each other, right?
Yeah, hopefully.
Yeah.
Hopefully.
I'm concerned about time. We're kind of at the end of the slot, so
downref. You will have a downref. It's not a problem. You can have a downref if you want to have a downref, or maybe there's actually. I don't understand why. I think it should be a normative reference. How can you understand the API without reading the architecture? Yeah.
Yeah.
So anyway, so you can have a downdraft, that's not a problem, you can have it, but we also had documents, architecture documents without normative language, because that's not like that, this is different criteria that have been published as proposed standard.
Okay. Thank you. That's good input. Pete? Also, I want to point out, Spencer is in the line. Did anybody notice that Spencer was in the line before I cut the line? He was. Okay. We'll get Spencer the last word.
Pete Resnick and Spencer made me get up to the mic. Didn't really want to. Folks are getting themselves wrapped around an axle here. 2026 allows proposed standards to be technical specifications and applicability statements. You don't have to have technical specification to have a proposed standard. Second thing, proposed standard is part of the standards track. There is an expectation that you revise it, and maybe it will recycle at proposed, or maybe it will go to internet standard. It's a track, and you can continue to make changes to a proposed standard, although the entire internet runs on proposed standards, we know.
Internet drafts.
Yes, internet drafts as well. Experimental should be there for when you're not sure what the outcome is going to be like, and you want to do something off in a corner and not have it deployed on the real internet. You want this deployed on the real internet. I don't see any reason for this not to be all of it, standards track, be done with it. We've done informational of protocols when it's not our protocol that we've developed and we just want to let people know, here's a protocol, but we're not recommending it for something. This is proposed standard.
Okay. Are you speaking as Pete or as Spencer?
I'm speaking as Pete.
Okay.
With hats removed and nothing. Yeah, no, Spencer just made me get to the mic.
Thank you, Pete.
Jonathan Lennox. I mean, the one thing, I guess, sort of building on what Colin said about, things that would be, if you don't think something's implementable. The only thing I think is if you think something might be dangerous, like, an attractive nuisance. And the example I could have is if you had like a way for people to plug in their own congestion control algorithm or something like that. I don't think, if it makes you go, oh my God, that's horrible, then you certainly wouldn't, maybe you don't want to do it at all, which is also possible, but, certainly, or if, you're defining the interface to something that is itself an experimental protocol, then that would be something but I think that would be things that could be peeled out of the core document, right, and also proves that the extensibility mechanisms work right.
Right. And NetDev was last week. So, okay. So I want to take Spencer.
And a bunch of the things that I was thinking people have already said, but I did want to mention two things quickly. First is, and that's actually kind of echoing what Jonathan was going with the, is there a concern about the impact of this on the internet? I know that if what we were doing was selecting between TCP and SCTP, there would not be. But that, it's the working group to think about that a little more broadly. The other thing I was going to say was I've done a lot of flexible things when there was a good description of what was going on in the Shepherd write-up. So, if at least one format of the Shepherd write-up says, like up front, why, what publication status is being requested and why. So, you can do, just tell us the ugly truth and we'll do the right thing. And with that, I await you all's recommendation. Enjoy Montreal.
Thank you, Spencer. With the I'm going to take a few hums with the assumption that we can hold publication of the document until we get some implementation experience. Let me start with the interface document. Can I get people to hum if they feel like standards track is the appropriate track for this? Okay, and can I get just the interface? Can I get people to hum if they feel that experimental is the appropriate track for this? Okay, for the minutes, so let's say that there was a strong hum for standards track. There was a small hum for experimental. Is there any, would anybody like to hum for informational for this document? No hums for informational. Okay, the architecture document. Let's have a hum for standards track for the architectural document. And a hum for informational for the architecture document. So I'd say a strong hum for standards track and a light hum for informational. Implementation hum for informational document for that. And does anybody want to hum for something other than informational for that? Anything else? Hum for anything? Yes. I don't want to go through like the complete space here. John.
I mean, the one thing I feel like, I mean, I've read all the documents at once, so I might be misremembering, but I feel like there was some stuff in implementation that described how interface applied to particular protocols. And I think that would clearly need to be in something standards track.
Tommy Polly, Apple. So in general, I feel informational for implementation just because that's the part that this is more of a guide. I feel less confident on specifying it all there. Now, the point about mapping specific protocols into how they behave deterministically within the API is a really good one. And what we may end up doing, especially for new protocols, is having separate documents which are proposed standards of here's how you map quick into TAPS, here's how you map that into that. And that may not at all be, like the implementation draft may define like you can have these types of documents, but it may not actually be the definitive reference for any particular protocol.
Okay, so, yeah, Brian.
Brian Trammell, one more on that point. And I would say if there are, if there's the temptation to add normative language to the implementation document that says that you must have this behavior, then any must on the behavior needs to pop back up in the interface, right? Yep. So it's like, 'cause that's part of the contract, so.
Okay. And let me just take a final hum. How do people feel, hum if you're in favor of getting implementation experience before we forward these to the IESG, because our schedule currently doesn't really allow for that. And my feeling is that it's a good idea, but let's just have a hum in favor of that. And how about a hum in favor of moving as fast as possible to get the RFCs out? Okay, I think that was unanimous. Okay, so it's one. Sorry.
Colin Perkins, I'd actually, in many ways, suggest we're stronger than just implementation experience and want 2 implementations for most things.
Yeah, I think the criteria, we should figure out what the criteria are for how to exit this, but I think that it'll be easier to do that once we really get into it. But that's a good point. Okay, sorry this ran a little bit long, but this is very helpful. Thank you.
So I think the hum has been noted down. Dr. Pierce.
Teresa, did you get all that in the?
How do we download this?
You want me to do it? You control W for some.
I think you can do it.
It's hard to do it on the fly.
Yeah.
It's a Chromebook.
And it doesn't listen to me clicks.
So
You see that control shift.
oops, wrong one. I can't be trusted with these things.
All right.
Okay.
Yeah.
Hello, everyone. I'm Tommy Polly, and I'll be sharing with you our updates to the architecture draft for TAPS, which apparently is now going to be a proposed standard. So I'm going to go probably a little bit shorter than our expected time for this to make sure we have enough time to talk through all the interface details. There are just a couple different updates I wanted to give. Most of the document is the same. We did do some editorial passes for NITs. Thanks, Corey, for a lot of those. So we've updated this as an 01 document just before the deadline recently. And there are 2 main sections that have been added, which I would love all of you to read and consider. There's one that discusses a concept which was not previously defined, which we are calling protocol stack equivalence. And the other one is a section I think Colin added on message framing and parsing, which was something that had not previously been fully covered in the architecture, which is a fairly fundamental concept and so needed to be addressed. So first, protocol stack equivalence. So we already had the definition of a protocol stack. Essentially, this is one thing that you can have as your candidate set of options to actually send data out into the network. This includes any framing or application protocols that you need, your transport protocol, and your IP protocol options. And this would contain and carry along with it any of the protocol-specific options that you had from the application. And so you have multiple of these candidate protocol stacks, and the idea is that you could do racing between them, you can be flexible, you can swap them out as necessary. But the key thing that we needed to define in the architecture is when is it appropriate and when is it possible to do this kind of racing or swapping. This is a hard question, and so we called this the equivalence. And I essentially view it as meaning that these two things are isomorphic from the application's perspective, and you can swap them out safely. And if they're not, then you should not be doing any type of racing between these without the application being fully involved. So we came up with a list of a couple requirements in here, and so I'd like to share them, and if there are any things that you think are missing or that you'd like to disagree with, please speak up now or raise an issue on the GitHub. So the first item is that the two protocol stacks must have the same API surface. This seems pretty clear. Just quoting directly from the document, they must offer the same interface to the application for both the connection establishment and for their data transmission. So the simple example here is saying that if I have a datagram or messaging interface, essentially when the application is being guaranteed that their sends and receives have preserved message boundaries that are actually transmitted across to the other side, any stack that I'm switching between must have that property. So I could use UDP because that has well-defined message boundaries, but if I wanted to use something on top of TCP, I would need some type of framing layer that actually delineated where the messages are. This could be something like HTTP, this could be just a basic TLV, but something has to do it. And so if we had just UDP versus TCP, those are of course not equivalent. And it's a fairly obvious point, but I think it's important to make because this applies to any of the bits of the API surface that we're working with. The two stacks also must have the same transport services that they offer, but these are in context of what is required by the application. So if the application requires reliable transmission, then, let's see, I think I have it backwards. Yes, sorry, those labels are wrong. Swap the labels, I'll update the slides for you. So if the application allows unreliable transmission, then a UDP interface is indeed equivalent to a TLV interface over TCP. One does offer reliability where it is not needed, but that isn't a problem if it's not necessarily required. However, if you did require reliable transmission on both sides, again, flip these, then they would not be equivalent. So protocol stack equivalence is dependent to some degree on the application required properties. Colin
Perkins, yeah. That's one we have to be careful of because requiring reliability affects the timing.
Timing is another thing.
So there are knock-ons between these.
Yes, yes. So if the only thing the application said is, I don't need reliability, then it may be okay to put this over TCP. If it is, I need this with certain timing requirements or not head-of-line blocking, then that wouldn't be appropriate. So the outcome of a lot of this is that you have to be very careful with these, and there are a lot of stacks that may look equivalent that really shouldn't be. So let's be very careful. Let's not break the internet. And then the other part, and Chris is not here, but he contributed a lot of text to that, is saying that they have to have the same security properties. And where we landed on this, to be safe, is to say that you really have to have identical security protocols to ensure the equivalence. So you can have different stacks that both include TLS 1.3, for example. I could be running a H2 stream as my transport stream, or I could just be using a TLS stream directly. But if they're using the same version of TLS and the transport stacks otherwise offer me the same transport services, that should be okay. However, if I have even the same TLS protocol but a different version, then that should probably not be considered to be fully equivalent. Yes.
Would, Jonathan, so I guess my first, would you consider DTLS to be the same, and given the caveats of the previous slides?
Right, that's an interesting question. So I think Chris's answer would be no. I think this is something we should debate and discuss more in detail. Like, for example, if I have DTLS 1.3 and Quick, if Quick offers unreliable datagram frame transmission within it, are those equivalent enough?
Yes.
We should look at that.
Yeah. And then the other thing is if, on one thing I can do, 1.3 or fall back to 1.2, and the other one only supports 1.2, those are equivalent because 1.2 is allowed in both cases.
Right.
Kyle Rose Akamai. So I'm going to be put in the interesting position of arguing against something that I'm going to be trying to argue for in the presentation later.
Great.
But the problem that I have with this framing is that it's even for the same security protocol, you could introduce, say, side channels because of a particular transport layer property or application layer property that would differ. That would cause the security layer to reveal different information, right? So they're not really equivalent necessarily anyway. It's also the case that by making this the requirement, then for instance, GQuick is not equivalent to anything because nothing else uses quick crypto. Correct. So I'm wondering if what we should do instead is have a requirement where we punt to the security area. Essentially, what is the bar that each of these things satisfies, right? Like basically, if you want security, you define some framework where you say I need these properties out of the security layer, and therefore any of these are good enough to achieve that, and that's how you decide which ones are equivalent for your application's purposes. I think there might be something more. There might be something richer that we can do that would be more meaningful from the perspective of deciding whether different protocols are equivalent.
Mm-hmm. Correct. Yeah, a couple of responses to that. One, I agree that we should, again, loop in security area to get advice on this. I think the point you brought up specifically about different things being given away is one of the reasons that Chris was arguing against making DTLS 1.3 and TLS 1.3 equivalent, because they also have such a different interaction model with their underlying transports that they may be giving away different properties. So I definitely think that's something to look into. Great. So that's that. Comments and stuff on the GitHub would be very, very welcome, or on the list. The other area is message framing and parsing. So this defines that we do have a focus for data transfer around the concept of messages. Protocols that natively support messages translate very naturally into this. And it does briefly mention how streaming protocols are really only preserving one message boundary, which is the end of the stream. And so this implies that in order to be able to usefully have multiple messages within a stream, you do need a concept of message framing that can get pushed down into the protocol stack. This is already all in the interface. We're just kind of bringing the abstract definition of it up into the architecture. So as far as what's left open issues here, I think one of the big things is a bit of document restructuring. Currently, these new sections that I just mentioned are tagged on at the end of the document. It doesn't really flow particularly well that way. I think we need to introduce the concept of messages and these ideas at least earlier up in the document, even if they're just referencing back to the main text, which is later on. So we're going to do some wordsmithing there. If people have thoughts and opinions, please share them. The other thing is we definitely need to fill out our privacy and security consideration sections. I think part of that will be taking more into account of what we were just discussing as far as security protocol usage. And then also we do need to look at how we are handling storage and caching of data. If we're doing this across connections, we need to make sure that anyone using this type of architecture is not accidentally leaking information across boundaries in which they were not intending to share data. So if this is all within one process space or within one system, we need to make sure that the data we're using to be smart about how we erase connections and resume connections is properly isolated. I think that's going to cover that. So that's all I have. If there are any questions about architecture,
I got a question for you, Tommy. Just kind of a management question. It's just based on the issues that you're raising. It sounds like this document is mostly complete. Would you say that?
Right. I think it's at this point, the scope covers mainly what we want to have. We definitely want to keep refining it as new concepts do come up in the interface. But I think it's going to go into more of a reactionary mode pretty soon.
So you don't have a lot of, other than the two things that you just mentioned, you don't have a lot of other holes.
Right. This reflects the open issues that we currently have. Yep. Yes.
Gori Fairhurst, there may also be perhaps a few more architectural pieces which we want to keep vague, like perhaps this policy stuff we're going to talk about later has to somehow fit into the architecture and be described in a nice concrete way without pinning it down into kind of real definitions. So I think there's probably a need for a few more revs of this to get this right.
Right. And I think those are going to hopefully align to the new texts that we add in the other drafts. And that's why I say like mainly reacting to flesh out the full picture.
Sure.
Show of hands, who's read the document? Okay. It's good. I recommend it. So if you haven't read it, you should look at it. Thank you, Tommy.
All right. Thank you.
That doesn't do it. Oh, there you go. That's
So while they're messing with this, I'm Brian Trammell. I'm going to be talking about the interface document, which compared to the architecture document is currently kind of an incoherent mess. So please read it. But in the architecture document, if you read it and you don't understand it, that's a bug and we need to hear about it. And if you read the interface document and don't understand it, then we probably already know. We're going to have a little bit of a discussion about some of that. So basically, the reason that this is currently incoherent is this is not as done as the architecture document. So we're revving this much more quickly. Actually, I think you can go to the next slide while I'm rambling on here. Oh. This is, the design principles. This is basically just a review. We haven't changed these. That's good. We think the interface design principles are correct. We're kind of following the process of like working on all of of turning this into a coherent and consistent implementation of the architecture or projection of the architecture into something that's implementable. And basically, we've been working on that continuously in fits and starts since London. And what we see today is a just before the deadline snapshot of where we were. There were a couple of large things that we did to the document that took a fair amount of effort. Those are done. And then we basically kind of like we need to go. And we have a growing list of issues. I'm just basically putting this up here for people who haven't seen what this document. I'm not going to read it to you. This is just sort of the review of what we're trying to do in this document. This is the interface diagram as of 0.1. Things in red are changes since 0.0. We have some terminological changes. These are called properties now as opposed to parameters, I think they were. We realized that you actually need a way to stop listening. Thank you, Jonathan. It's like you could stop listening before. You just had to take a pre-connection and crash out the application, which is probably not the best way to do it. We added message contexts and end of message in order to support partial sends, which I'm going to talk about in a moment. We added received partial as an event for partial receives. And we actually made it clear that data and metadata are associated with the received event. So with the received metadata, for example, that's all the way down to if the stack supports it. You basically get this object that everything that the stack knows about the message and is willing to share with you comes up. We haven't really made concrete what it should or must do yet. That's in the future, but we've said that this is actually part of it. And to some extent, it might even be what exactly, here's the minimum contract of what that's going to share with you, but what exactly is stack and implementation independent. It's going to be interesting because I have some animations and they're not going to render. Okay, good. So non-editorial changes since 00. Yeah, these are basically the 6 pull requests that we got through. We're only going to spend time talking about the top 2 today because they're the big ones. Is this the point that you want to come up? Okay. Actually, no. I'm going to do this one. Then you can come up after. Philip insisted on giving this part, and I actually am going to be out in the audience heckling him because of this point. Right? Oh, wait. Whoa. We don't think we have this right yet. So we're kind of, we basically snapshotted. There was a gigantic editorial change to take all of the various places that we were talking about, properties and parameters, put them in one gigantic pile so that we could try to systematize how we talk about them. And we have at least 3 proposals for systematization. I think actually probably we're going to interrupt in the middle of this and then go to Tommy's proposal for that after. So we actually, the slides that Tommy sent, I think we want to insert in the middle of this talk.
That's fine.
Okay. Yeah, so I'll say when. So yeah, the new approach, we basically take all the parameters that aren't security parameters and we called them properties. We stuck them in a new section. This was a really useful exercise because it allowed us to see where all of these things were. Like the document distance between these was pages and pages and pages. And out of this exercise, like the first thing we found was just, we actually did some copy paste errors, like some editorial stuff, or we didn't think about how these things interact. The basic mechanism by which we do transport protocol selection, which is sort of the important TAPSy part of TAPS, is pretty much the same. We still have preferences. They're expressed using requirements, preferences, avoidances, and prohibitions. And then new, because of how we interact with partial sends, information that's on a per message basis is bound to a message context, and then you can keep sending data to that message context. Probably we will recommend, for the common case of not doing a partial send, we will recommend syntactic sugar for papering over that. Is it in there? Oh, excellent. So this is the part at which Philip wanted to come up.
So we were thinking about how to structure these now called properties for the various effects, how to send stuff, how to send messages, how to do the selection. And we basically started out sorting about different things. So first we clearly defined data types. They were in the old version, they were just described in the text. So this is more as a Boolean. Now we somehow came up with some kind of structure that can be also used in later documents that, for example, define properties for certain other protocols. We added a scope describing whether these properties apply to pre-connections, connections, or messages, which is also pretty clear, which also enabled us to deduplicate some properties that were once defined for messages and for connections, but apply to both. Then you can just describe the one thing and say, okay, it applies to pre-connections and connections and to messages. And finally, we have the need to, we were thinking about whether we need to classify somehow the properties by the Gestalt, how they work, and what effect they have. And I think this is the most controversial one because this kind of classification we did there is more or less the, let's say, upper bound of detail one would want to have in a classification. So therefore, it's really an upper bound proposal that may be cut down later on. We're aware of it. We're not insisting in having it that complex. We just want to, in the working group, to think about this process. So first, there are 2 aspects to classify them. One is whether is the level of abstraction. So whether they have an immediate meaning, so whether you can just go into the implementation document or the API document and say, if you set this property, it will have the following effects on the following protocols, and you have a clear meaning that will be consistent about all implementations and that will be consistent on all environments this application is run on. And we have stuff that is interpreted. So as in the current version, we only have the capacity profile property which is interpreted, but it can have different meanings depending on the environment it's run on. And during a discussion with Gori, I think it's really, he convinced me that it's really important to at least tag properties, whether they have an always, I would not say consistent, but at least consistent meaning, or they are interpreted by the transport system. So that's one dimension of the classification. The other one is what these properties mainly target to control. This is, in one case, the selection, protocol, and path selection. This is in the second case, some of the protocol operation, and that's for some that were mainly left coming from the message context, properties that control how the transport system actually works, and this that changed the state of the transport system itself in difference to the protocols. As we had, they were neither clearly being protocol properties nor something else, we made up a new box and called them control properties. Maybe we need to structure this completely differently, but at least we needed some box to put them on and make sure that they are a kind of different beast than the properties that are used to control protocols. Yeah, this was mainly what I wanted to show here. Brian, will you go through the table? Yeah.
Time check. You're about halfway through your time. You got 10 minutes.
Yeah, good. Everybody can read fast, right? There we go. Okay, we're done with that. Yeah. So we actually took these sort of axes and applied them to all of the properties that we have. You can see some question marks in there. These are things that we're not even actually sure are properties. I'm not going to go through each of these. I'm just going to ask people to have a look. So, you know, here, type is the data type. I actually think the data type is useful. We should keep it. It turns out that we do actually have this horrible thing, which is when you're talking about interface and PBD instances, you have to have an enumeration / preference tuple. We maybe can do that a little bit more cleanly. The scope is, does it happen on a pre-connection? Does it happen on a connection? Does it happen on the message? The protocol and control properties are here. The selection properties are here. This dependency means in a lot of cases when you have a message property, it actually depends on a protocol selection property to have been applied to the pre-connection, right? Like say you basically can't have a per message reliable transfer if you didn't select a transport protocol that configures reliability per message. There's an open question as to whether or not doing stupid things is an error or just ignored by the system. Like we just need to make a choice. That's a bike shed, and we can paint it. Looking through these though, you know, there's a lot for, you know, controlling how you send messages. There's this checksum coverage thing, which came out of Minset and UDP Lite. There's one intent, which is the least horrible name that we could come up with. This is called capacity profile. It basically means, do I intend to send traffic in kind of an interactive way or in kind of a bulk transfer way or in kind of a scavenger way? Just basically talking about sort of the capacity profile. That's the best word we can come up with. I don't quite want to wordsmith that right now, Gori. I only have 8 minutes. All right. But like we have this, you know, we went through this whole sort of orthogonal sort of thing. Oh, and then there's all of this stuff for, you know, buffer sizing, right? And these are sort of read-only, right? It's like once you select a transport protocol, you might actually want to know how big the buffers are so that the application can figure out, you know, how it should interact with it. We tried to do these as axes, and then we realized that they're not orthogonal, which is kind of one of the rules for axes. And then I went through this list. We have like 6 distinct kinds of thing, right? So very clearly, we have preferences used for selection. We have a property that controls how the message is sent in its scope to a message, and it's usually linked to a selection preference. We have a property used to control operation, and it might be usable for selection as well, right? Like, so for example, if you're going to say, hey, I need a protocol that's going to allow me to send atomic messages of 128K, good luck. The system will go off and implement and define a new transport protocol for you, I guess. Then you have, properties to inspect protocol operations. So these are all those read-only things at the end. You have the special snowflake, how you figure out that you're going to bind something to a set of interfaces and or provisioning domains. And we went back and forth on this one for a while. I think we actually got this one in before London, right? And this is the least bad way we could come up with it that fits into sort of the way that we did things. We might actually, these are special enough that we might actually want to treat them entirely differently in the API. Like, so we need to probably even file an issue and say, let's go back and revisit this. And then we have intents, which are, sort of down at the bottom of that thing, because they're entirely different in how they interoperate or interact with the system. Like an intent can be used at any scope and can have sort of like higher order effects on how things are put together. From an implementation standpoint, I'm not entirely convinced that intents aren't like another layer on top of this API, right? Like, so you have an intents-driven API that lives on top of this one that basically turns your intents into these 5 types of properties. And then maybe, they're implemented in the same way, they're implemented in the same stack, right? But simply because, and actually the exercise of putting it into that, into this thing over here kind of shows they're different, right? So that's that. I'm going to open this for 45 seconds of discussion. oh, yeah, no, right. This is the point that you need to drop in. Yeah. Yep.
I can just talk from over here. This is Tommy. So we were discussing this a little bit earlier, and so this is a very nascent idea. Did it actually get uploaded?
They didn't make it back. They're in the meeting materials. I don't know why it's not there.
Essentially, before we get the slides up, the idea.
So basically, let me introduce. So this, so idea one was, okay, let's try and put this in a whole bunch of sets of orthogonal axes. Actually, on applying that, and this is just my opinion. It seems like we have a whole bunch of points in that space that are not occupied and will never be occupied. And then I said, well, simpler would be to, classify it into these n kinds of things, which is actually kind of what we had before, but we hadn't really reasoned about it in any rigorous way. The downside of my proposal is that does my ad hoc classification work because of some essential aspect of the problem, or is it just the ones that we've thought about so far, right? So I don't like the non-orthogonality of it. And then at lunch, I think Tommy and Colin invented a third thing. So, take it away.
Yeah, this is just an attempt to try to graphically draw it out. So the idea here is, because Philip mentioned there's kind of a scale of, we have deterministic properties and ones that are more interpreted. And as Brian was saying, we could probably get away with maybe saying the interpreted layer is a different thing for now. And so the goal here is to allow us to very deterministically say what is going to happen in the system based on 2 categories of properties, which we actually get from the architecture. So the architecture defined general protocol properties and specific protocol properties. So here's how this could work out, right? So let's say I have a generic property about my type of congestion control that I want, and I say, I want background style congestion control, which is a very concrete thing to ask for, but it could apply to different protocols potentially differently. As opposed to saying, I have a very specific protocol property, like if I'm using TCP in this connection, use LEDBAT. So those are 2 ways to specify this. So next slide. Actually, one back. Yeah. Nope. There we go. So the way that this plays out deterministically is that if I use a generic property, I don't know which one I'm going to get, but we will have a specific mapping for every protocol that we can actually define in a spec somewhere, saying that when TCP is running and it sees background congestion control, it will run LEDBAT.
And if you say require background congestion control, and you have a stack that doesn't offer it, then
you would fail.
You're dead.
Right.
Yep.
So it actually creates a very deterministic way to select which protocol stacks are even eligible here. And then let's say Quick comes up with a special background BBR, which is going to be called BB-Back or Baby Back Riz. So please, someone create this as a background quick congestion control protocol. Exactly. As opposed to saying, if I only want to use Leadbat if I'm doing TCP, that will not affect any stack that uses Quick. So it gives me the flexibility that I need from an application standpoint, but also makes it very deterministic, and we don't have to worry about an application saying, oh, I want this property, and maybe it's interpreted one way today by the intents engine, and then we can never really change it because they relied on that. One last slide, something that Eric brought up when we were discussing this earlier. We could also do a cute thing of, rather than having the options for TCP ever be called Leadbat, just have it be TCP's background congestion control, such that the types are always the same, and we just say it's more specific to certain protocols. So this is an idea that we could start to explore for categorizing things, and it fits a bit better with the architecture.
Cool. So right before that,
You got 1 minute.
and to the end? Oh, all right. Yeah. Okay. Then we might have to bring this back at the end of the thing. But yeah, you know what? I'll take it offline. Wait. We have an open issue that I want to bring up. Tom, you got like 5 seconds.
So Tom Jones, just very quickly. I totally agree, and I agreed with them over lunch, but I don't want to build in a massive database of
Right. Yep.
properties and mappings.
Yep. There's another thing that came out of that, and I don't think we say anywhere in any of the documents that we require deterministic outcomes, and we should probably have a statement about that. Somebody file an issue.
No, you skipped a slide. That one, yes.
Oh, yeah, right. Oh, partial send and receive. Oh, that was what you wanted to say. Okay, cool. Anna, how much time do you need? Can I have some of your time?
Yeah.
Okay, cool.
I think this is the draft we has mainly updated.
Okay.
Kyle, do you need all 20 minutes for yours?
You can take 10 minutes from.
Okay, I'll take 10. Okay, good. All right.
Saved by the bell.
Yay! Wait, as long as I negotiate for more time before it runs out, right? Like the door doesn't open and I stay here. Okay, good. So partial send and receive. Did you have a question about partial send and receive? Should I run through this real quick?
Run through it, and then I have a comment.
Okay. The API on purpose is organized around atomic read and write of messages, but it turns out that buffers have finite sizes. Yeah, it's kind of unfortunate. The solution here, well, and sometimes there's actually an application layer thing where at the beginning of sending a message, you don't know how long the message is going to be because you're actually streaming something off of something that's actually a physical stream. But most often this is, you have an object, your higher layer application thing is, oh, I want to send the entire JPEG, and the JPEG is huge because it's like the Hubble deep field, and okay, well now you need to do a partial read write. So the way that we did this is it inspired by or stolen from the API so the Apple implementation of this? It's pretty much straight up how they do it. Where send now has an optional parameter that says I'm done sending or not, and there's an object that you bind that send to, which is the message context, right? Like so, in an object-oriented, like a classical object-oriented programming language, you could implement this by essentially saying, I'm going to create a message context for sending bound to this connection, and then I'll just keep writing bytes to it. There are a bunch of different ways that you could sort of project this into different languages. As long as you don't say, I'm done, as this is the last write, and you can actually have a 0-byte last write as well, right? Like, so you can essentially say, I thought I wasn't done, but now I'm done. Once you say you're done, then the message context closes. On the other side, when you receive a partial message, so a message that the system does not know is the end of a message, either because it has protocol layer framing because it was UDP or SCTP, or because the deframer actually detected end of message, but it's still larger than the buffer, you will end up with a received partial. Of course, partial read-write boundaries are not preserved, right? Like only the message boundaries are preserved across the send, assuming that you have either framing in the transport protocol or a correct deframer. So this complicates the API somewhat in that you can never be guaranteed ever that you're not going to have to handle receive partial. but it allows us to essentially flexibly handle sends and receives in a message atomic fashion without requiring everything to be under the size of the buffer. So, Colin.
So, hi, Colin Perkins. So I think if you look at the architecture, we have quite a nice high-level view of things where you're sending and receiving messages and putting the framing and deframing of those messages down into the stack.
Yep.
I think this is kind of losing some of that. It's pushing some of the knowledge you need to do the framing back up to the application. So I'm not sure we quite have this right.
Well, so
now that may just be that and I mean Tommy has comments about bank pressure, and I get that, and I think we have to resolve this somehow. But the idea of sending a message object which can then lazily load the rest of the content, for example, would seem to match the architecture better to me.
So the downside of that, of course, is that you might end up with unbounded buffer attacks, right? So
I don't think any more so than this. It's just it's moving the complexity around.
Right. Yeah. Okay.
And
right.
It's probably more natural to implement in some languages than others, and we may be able to come up with wording which satisfies both implementation styles. But
so yeah, we landed this in order to be done for in order to have an answer.
So I think what we have is a good starting point.
Yep.
I'm not sure it's quite right.
Okay. Cool. So we'll keep working on it. File an issue, assign it to Colin.
Tommy. So just to respond to Colin, I think what this raises when we look at the architecture versus what we have here is a bit of a philosophical question that we should all ask of, like, when we say this is message oriented, what is the thing about the message that we like? I see two possible answers to that. There's one that just means that message data has well-defined boundaries, right? We want data that's not just unbounded streams. We want well-defined, preserved boundaries that are actually communicated between two sides of a network. The other one is that we can do things atomically. And this version of message has boundaries but is not atomic. It can sometimes be atomic, but it recognizes that that breaks down. So if we define messages as well-defined boundaries of your data, then I think this does meet what the architecture needs, but it's a question of definition.
Mia Kuhlmann, I think I agree.
With who?
With with Colin, actually. It's clear that we need partial read because you might just not know where the boundary is, right?
Yep.
But at the moment where you send a message, it's a blob of data, so like it has a length, right? So you can just give it to the other layer.
Right. By default, that's right. Yeah. So the problem is this is a thing that only actually happens in a corner case where you're trying to send things too big for what the transport stack can give you, and to some extent, like so applications right now. There's no application that opens I guess there is send file. Okay, that breaks things. But that breaks things in more ways than one. But if you're not basically, telling the kernel to blit a file to a file descriptor that's also a socket, that might be UDP. Yay. Oh, what happens when you do that? Right. Well, in this case, that's the right question, right?
Brian.
Yeah, I know I'm rambling.
So you have 3 minutes. Do you have any other topics other than this you want to get to?
We have one more topic that's a gigantic bike shed.
Well, you're going to have to choose whether you're going to let these guys talk or you're going to...
Yeah, no, I think that what actually has come out is that we need to have a talk about this. Let's
do an interim on it.
Okay. So we have one open issue, which is hard to follow because we did half of the discussion on the issue and the other half of the discussion on the PR, because Colin wrote something that he thought was a pretty good idea, and then I said, no, this is terrible. And then the end of the no, this is terrible, were 4 options called option 1, option 3, option 3.5, and option 5. There's also an option 2, which I wrote down, but when I was making this slide, I realized I didn't understand it anymore. So Basically, this is the Apple versus Linux. How do you do TCP fast open fight? The first option is that you make everything explicit.
You can't do TFO way one with OpenSSL at all.
Right. Yeah.
Right?
Okay.
So,
Yep,
so
yep.
if
Yep,
it's not
got
the
it.
beauty of the
Yeah,
implementation.
right.
It's
Yep,
like,
yep,
does it
got
work
it.
or not?
Yep.
Mia Kulin, this time I disagree with Colin. I thought that
This is why we have meetings.
I thought the whole exercise is to not let the application choose specific protocol properties. I think that's like the whole exercise.
Right,
Yes,
so-
there is a security risk, right? But like, first of all, you have to negotiate TFOs in a previous connection, right? So you have to have the how's it called, ticket
Yeah,
or
right,
whatever.
yeah, right. So-
Otherwise, you cannot do TFO.
So the problem here is that zero RTT is a very special snowflake.
I know. So what we should do is like we should say if a message is idempotent or not. By default, it's not idempotent, so you cannot use it, and you have to actually declare that it's idempotent. And whenever you have an idempotent data and you have session keys from a previous session, you can use TFO.
Of course, yes. Well, we know that, but the problem is that how do I keep the thing from running the connect before I've sent?
Because you know you have session keys.
Okay, so that's option 3. Or 3.5. So if the stack knows that it can zero RTT because it has session keys, it actually then says, screw it, I'm not even going to try racing. Because there's a racing, yeah, there's a racing problem here as well, not like a race condition problem, but a connection racing problem here as well.
Can we talk for a minute how you're going to pick one of these options?
Yeah, I think we're going to do a bit of a survey, and then we're going to flip a coin, and then we're going to a 3.5-sided coin. Yeah. And then we're going to argue, and then something will fall out of that. And that's probably an interim, that's a virtual interim topic if we don't fix it sooner.
Teresa, can you note the 2 topics that we said are going to be good for the interim so we can pull those out for the agenda later? There's this one
Perfect,
and then
thank
the partial set. Yeah.
Partial send and receive, do it better. Yep, good, excellent. There are other open issues. I'm sure that we've actually added more. I sent some to the list. Please comment on the list and or in the GitHub issue tracker. Thank you very much. We hope to have a better document for Bangkok.
So Anna, you think you can do it in 10 minutes?
Yeah, I can do it. That's problem.
It does have to be comprehensible.
Yeah.
I think it's in the tab. You just can't see the tabs.
Yeah. How do you open the tabs? That's fine.
Okay, good. So, hello everyone. I'm Anna Brunström, and I'm here to give you an update on the implementation draft.
Oops.
Yeah, so just to start to give a recap of the scope. So the implementation draft is the 3rd draft in this series. So it gives some guidelines on how to implement the API that Brian was just talking about. So it's a complement to the architecture and API draft. This draft has also not changed so much since the last time, not because it almost has everything in it, like the architecture draft, but because as you saw, we're currently debating what the API will look like. So it's hard to see how we implement it before we actually settle on some of these issues for what the API would look like. So it has become a working group document since the last time. And the 2 pieces of information that have been added in terms of any content is that there is some further information on how to use the transport properties during the selection of branches when you do the connection establishment. One of the updates in the API that Brian did not have time to talk about was that there is some new text on how you do batching sends, and there's also some matching text for that in the implementation draft. So those are the 2 pieces that have been added. So we have a number of open issues for this document. Also, there is some structural parts. So one aspect is the system policy and the caching and how that will come into the implementation draft, and that will also be related to the discussion that comes, how we will deal with policy in general. We have 2 sections of the document that has to do with the connection establishment. So we have one section on rendezvous and discovery steps that are now in its own section, in section 10, for peer-to-peer connection establishment. And then we have another section 4 where we have the text on candidate gathering and racing for the other protocols. So these 2 sections need to be integrated and generalized. And we also have some alignment of terminology and those pieces when that settles in the other drafts. We have a number of missing pieces in this draft. So here, once we have settled how the protocol and path selection properties are defined, we need to have the mapping for what they actually means in the implementation. So this is, of course, waiting for this part coming from the other sides. We need a privacy consideration section for this draft as well. We're going to add some pointers for the different implementations that are available. We need some discussions on threads and concurrency. There are some additions for ordering of API events that has gone into the API draft that doesn't have anything matching in the implementation at the moment. So we need to at some point see that we have matching things for everything. So in general, there will be a number of alignments with the architecture and API drafts as those stabilize. And details for all the open issues is in GitHub, so this one applies to all the 3 drafts if you want to see the details for what is under discussion. That's it.
So, anything you want to try to get feedback from the folks in the room on today?
Not specifically, because I think most of the things that we have open here are really depending on where we end up in the API, and then we need to do the matching part in the implementation draft. But we don't have any big debates here yet, because I expect they will come once we know what we actually need to map, right?
Yeah. Keep the back aside. Yeah, the mapping. So I guess this is related to Jonathan. Sorry, it's related to my comment when we were discussing the document status. The mapping of path protocol selection properties. If any of things of parts of that are something that actually should be, normative on the API rather than just implementation choices, then that needs to be something that can be moved probably into the interfaces document rather than here.
Yeah, I think this is something that we need to think about, how we're going to do this split, because we have, I agree that some of this needs to be standardized, but we also have the mapping for all the protocols, so it will kind of maybe be a mess if we move everything of that into the API. So we will have to think about how to structure this one, and if maybe some of those pieces should even be separated, but I think maybe we can deal with that when we have come to that point. But definitely that's something that we have to take into consideration.
So I see, hi Brian Trammell, I see from sort of the earlier discussion about status and how we want the workflow to go, and then like the state of each of the documents that we've had to this point. I see sort of like 2 kind of functions for this document. One is what we thought the original function of this document was to show that we have an idea about how to implement these things in order to justify their inclusion in the API document. Once we move toward more implementation from people within the working group, that function is replaced by sort of a implementation considerations function, right? So once we move into implementation, I hope that the workflow that we have is we dump observations into this document, they bubble up into the API document, and then anything in the API document that conflicts with the architecture might bubble up into the architecture document, right? So we've started this process sort of top-down architecture implementation, or architecture API implementation. Once we get into implementation phase, I think that we'll have a top-down, we're just going to flip the direction of the document. Does that make sense?
Yeah, if you have a stable version of the API, you mean,
Yes.
and then you start to implement
Right.
it, then of course,
exactly. Yep.
whether
So-
it comes through this document or it comes directly to updating the API,
Right.
I guess is debatable.
We can talk
but
about it, but yeah.
I think that the process certainly will reverse, because at
Yes.
this point we are focused, I think, as a group in the discussion for getting the API sorted out and kind of trying to verify that it can be implemented.
I'm happy that that suggestion seems to make sense to all the editors, because that seems to be what came out of this meeting. That's actually kind of a useful workflow outcome. So thanks.
Thank you, Anne.
Okay. Thank you.
So next is Tony. Let me get my notes. Time check over. We're on schedule if everybody stays in their time. And I think Kyle said that if we find that we need a few minutes, maybe we'll take a security discussion.
All right.
So,
All right. So while we're getting the slides up, I'm Tommy again. And now I think we're going to go into a section both of talking about implementation experience, as well as specifically talking about how we deal with policy and how the TAPS system interacts with the rest of the operating system. So what I'm going to be sharing here is specifically our implementation. So we actually, in June, when we released our new betas of iOS 12 and macOS Mojave, along with that, we have a new framework that's available, which is called Network Framework. Currently, all that is contained in this framework is essentially a new transport API layer, as well as things that allow you to look at your current network state. And so this transport API is where we want to be continuing to develop our TAPS layer. It does provide truly a post-sockets implementation. We do use sockets as a substrate when we need to, but otherwise we actually are running a user space stack within this. So we're trying to free ourselves from the shackles of sockets and see how things actually work in the real world. This is implemented both in C and Swift. The API interface I'm going to be showing here is just the Swift bindings, because I think that works a lot better when we're talking about some of the modern conveniences that we're discussing in the TAPS API. All of this is possible in C. It's a little bit more cumbersome and less clean. Stuart, do you have a comment?
Yeah, hi, I'm Stuart Cheshire from Apple. I just wanted to set some context here, because when you talk about public betas, that might mean months or years, and I want to set some context that what we're talking about here is this may be public beta now, but when iOS 12 ships, and you can make your own guess when that may be, this will be the official public API.
Correct. So if you are an early adopter and want to try it out now, you can do that. It's also available on our documentation website if you want to see what the API surface looks like in full. The documentation is not very well fleshed out yet still. So working on that. There are a couple sample pieces of code though. So just the objects that we're exposing here, we have some pre-connection style objects. We don't have something called a pre-connection, but we have a static endpoint object which can describe a host name, a bonjour service, address, ports. And then we have our parameters, which is essentially the rest of the pre-connection that isn't the destination you want to connect to. This has a lot of generic parameters, but it also includes a protocol stack, which is composed of various protocol instance options. So you can essentially build, hey, I have an option to have TLS using these options on top of TCP using these options on top of IP using these options. We have three currently different active objects: a connection, NW connection, NW listener, and NW path monitor. The connection and listener are pretty much exactly what we have in the TAPS API. The path monitor is this other thing that we have to essentially discover other interfaces and paths without actually connecting over them. This allows you to, if you need to have a different UDP connection or a listener on every single interface that matches a certain criteria, you can do that. Maybe that's going to be something that's similar to what we're going to need for ICE and other strategies going forward. And then there are two other objects that are used for more like introspection and dynamic interaction. There is a NW path. This is the thing that you can iterate with the path monitor, but you also get a path from any connection you create. So it says, here are all the network properties of the thing that you are using to connect on. And you can get protocol metadata, which is used for sending and receiving or just introspecting general state of your connection. What is my current TCP receive buffer size? So as an example of connection establishment, here I am creating a destination endpoint to example.com on port 443, which I have a convenience for as HTTPS. We can establish a connection to that endpoint using a set of parameters. In this case, I'm using a really stupid little convenience API initiator for the parameters of just .tls, and this says just give me the default TLS-like behavior over a reliable stream. You can go in and actually configure all the bits yourself, but that's just a 4-character way to say it if you don't really care. You can then say this, say a state update handler. The states I'm listing here, there's a ready state, which means you're ready to send and receive data. This is like our fully connected state in the TAPS API. It means that TLS is finished, TCP is finished, you're ready to go. We have a waiting state, which is actually very important for our mobile devices. Oftentimes you don't have a network at the moment, but you're about to have one, or you have a network transition happening. Rather than just failing, if you create a connection when there's not currently a network, we say, you're waiting, and we will automatically try to connect for you when a network does become available. It's not something we've really talked about in TAPS, but it could be interesting when we look at kind of multipath mobility aware transports, and failed if I have a fatal error. And then after I've created my connection and set my handlers, then I call start. So we did choose to go with the split model of create a connection object, set some update handlers on it, and then call start, rather than just having a single combined initiate. And that did influence how we did fast open. When we look at the data path, we have a basic send call. So in this case, the basic send, we create our data. In this case, I just want the bytes of hello. And I can call send on the connection, passing that data as my content. And then I have a completion handler, which lets me know if there's any error sending that data. And it only gets invoked when that data has been consumed and processed by the stack. So in Swift, you are allowed to have kind of optional parameters that have default values, such that when you're using the API, they're hidden from you. So we actually only have one send call. And so this implicitly has a end of message is complete flag that is always true by default. And it also has a message context parameter, which is just default message by default. And so I can simply call send with my data, and that is sending a message. If I do want to go in and say, oh, this is actually partial, or I have these special message parameters or properties, then I can add those, but those don't get in the way otherwise. We also have a operation for doing batching of sends, and this was really, really important for making sure we have good UDP performance if we're sending a whole bunch of datagrams at once. And so we can essentially just create a closure of a batch, and any operations that we do within that closure are assumed by the stack to be held until it completes. So we can say send, 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 and the stack will not intentionally try to process and drain that out until you're done with that batch operation. On the receiving side, we can do a simple receive. In this case, we just get our complete, actually this should be called receive message. We're only wanting to receive a complete message that has a strict boundary on it, and we get back our data, any context that has metadata about the message I received. It lets me know if it was complete or not, and any errors I got. If I explicitly want to receive more of a stream, I can set the minimum incomplete length that I'm willing to receive at any given time, and the maximum length that I'm willing to receive at any given time. So again, we have the, I want one message at a time, and I want to stream my data. Both of these work over TCP, and they actually both work over even UDP as well, if I just want to, for whatever reason, read out only parts of my datagram at a time. Looking into message contexts, the way that we did this, we have a content context object. It has a random identifier, so we can trace it throughout the stack better. And it has some of the properties that we've discussed here. It has an expiration. It marks, is it the final context on my connection? Does it have an antecedent? Are there extra metadata settings here? The metadata settings that we currently support are ECN flags for IP. We have a timestamp option now. Other good stuff. And then we also have some convenience send contexts. So the default one, whenever you're sending, is default message, which is, this is a message, it's complete. I don't have any other special properties on it. There's a special one for just, this is the final message. And there's also a synonym that we made for default stream. Some of the people, when we were reviewing the API, were concerned that if it was only ever message oriented, the people who wanted their TCP stream might be a little bit thrown off. So default stream behaves exactly like a final message. And it's like, if you use default stream, you only have one message and you can just keep streaming to it and then you're done. So if that's the world that you want to live in, if you want to treat things like a byte stream, you can, but it's not the default. So diving into a little bit of the implementation details here and how we are interpreting parameters currently, this kind of gets into our policy discussion. the application can constrain their path and their protocols using the parameters. So for here, for an example, we show requiring a specific interface type, or we can prohibit an array of interface types. And then here's a kind of just like a flow diagram of how the state works. So the application comes in with their parameters. When we're actually doing our connection candidate gathering, we run that through what we call a path evaluator, which takes those parameters and interprets them based on the system policy. And this may be things about which applications are used, so are allowed to use which interfaces, and what are the available interfaces at the given time. And then that all gets generated into the object which we call the NW path, which is essentially the current snapshot of the policy result based on the system policy and your parameters. And that can have on it one or more interfaces that you are allowed to use, and that essentially determines all of the rest of the machinery. And we have a similar thing for any per protocol or historical performance properties. Looking into how that system policy actually works, the system configuration itself determines a ranked list of the interfaces and they're, that are allowed to be used for default internet traffic. So generally this is going to be, if you have Wi-Fi and cell available, Wi-Fi and cell, but it could also be a VPN interface, and we can list all of the different default routes you have. And those could all potentially show up in your path. Most of the extended policies we have do occur on a per application or per process basis. Certain interfaces or interface types can be prohibited or required. And also I want to note that we have certain application parameters actually can be keys to influence which path you take. So your parameters could include something like, here's a specific account I'm associated with, or the specific endpoint I'm associated with, and that could determine, based on system policy, where you are bound. So the policies that get installed in the system can look like, if you are process X and you're marking yourself as working on behalf of account Y, then get scope to this interface. And so, as I said before, the path includes not only which interfaces you're going over, but the protocol settings such as ECN and TFO allowances and your predicted RTT, so we can do better happy eyeballs. So one area that I definitely want to see this evolve going forward is making this much more flexible for protocol selection as we get better options of equivalent protocol stacks to race between. Right now, the things are fairly static. You have a default stack. Let's say you create your transport options, you can put them in. Great, you have TCP, you have your options. It's not doing a lot of protocol racing now, other than in cases in which we have proxies or other things that we know really need to be interjected. So I think this is an area in which we need to look as a group of, do we have arrays of our optional protocol stacks if the application wants to explicitly state the protocols that it knows the server supports. We could also imagine more conveniences for creating these type of stacks in the future. So right now, the default protocol stacks that we can configure are TCP, UDP, TLS over TCP, and DTLS over UDP. But it'd be really interesting to say, I want a default convenience for things that look like quick or HTTP2, and essentially have that larger category such that the TAP system can determine where to put things. Yep, and here's just a lifetime diagram of our internal connections. I think it matches up fairly closely to the state diagrams that we have within TAPS, with a couple of differences. The one main one I want to highlight is how we've added that waiting state for whenever the network is not available. It's not the same as the failure, but we can't connect right now, and it's a useful signal. It has an interesting property of that's the one state that can kind of go back and forth between actually setting up and being in this holding place. And that's all I have. So if there are any specific questions, please.
I have just wanted to jump the queue and ask a sort of a working group chair kind of question. So first, how well does this match up with the proposal as it's currently defined? And how do you feel about continuing to move closer to that as it evolves? I'm asking Apple.
Right. So I mean, I can't speak on behalf of all of Apple. I don't know what the future will be. Specifically, I think things do match up fairly well with the overall interaction model. I think right now our data path is quite similar. Some of the areas that are different right now are in the way that we specify the pre-connection, how we specify these properties, because this is also the area that's fairly flexible in our own documents. This is an area in which I think as that becomes more and more clear, we will probably likely want to add those knobs to this API. We may not necessarily remove other ones. So it may be a little bit a superset of the TAPS API. But I think having something that would conform to the general model that we're designing here is a goal.
That's terrific.
Hi, Colin Perkins. So the beginning, the sort of left-hand side of this state diagram sort of breaks down what I guess we're calling pre-connection things into a few more states. You've got the waiting state, and you've sort of broken things down a bit. Do you think that's something we should be trying to incorporate into the TAPS API?
It's something I wanted to share. I don't think it's an essential part from the perspective of TAPS as transport protocol agility, but I think it is important as a overall concept of moving beyond sockets, especially if we want to be affording for very mobile type of networks in which things are coming and going.
Yeah, we should maybe think more about how we represent interfaces and their availability in TAPS.
Right.
I think we haven't really discussed too much yet.
Right.
Kyle Rose, Akamai. Is there any hierarchy within the properties, or are they all? So, for instance, is there any encapsulation for the path elements? It looks like they're all at the top level.
Right. So this is something that we looked at, and I think we will want to probably add hierarchy as things are defined within TAPS, because I think hopefully we'll get to a better structure. Right now, we've tried to constrain the number of top-level parameters we have. We do have them, mainly they're around path selection and not protocol selection. Those ones are fairly top-level. The things that we have done for specific protocol options, we do have within a hierarchy. They belong within the protocol stack, and so those we believe are not going to conflict with the model in which we are actually racing between different protocols or being more flexible. So I think protocol options right now have the hierarchy, but there is a flat area, and I think that's an area I want to see this evolve.
Right, because one thing that I've been thinking of, a use case that might be helpful, would be being able to race between two different MPLS paths, right? Maybe, I don't know whether that's in scope for TAPS or not, but it would be an interesting use case. So one other minor nit, I think I'd like pre-connection better than endpoint, just because the pre-connection incorporates more than just the endpoint properties, right? It includes the path and whatnot.
Right. So I think, to be clear, the thing that we have as pre-connection, I consider to be equivalent to the tuple of our endpoint and all of the other parameters associated with it. So there definitely is it's not a clean mapping in that regard.
Okay.
Hi, Brian Dremel. This is actually the first of many questions I'll probably be bugging you with over time on sort of feeding your experience back into the working group. I like how you said, yeah, we're going to move toward this, but we're not going to remove anything. I think that it's actually kind of, and we want to be a superset. I think that most implementations of the system should be a superset of what we specify, right? Like we should be specifying something that is as scoped as possible to the stack agility stuff that we are chartered to do. I think that, when we can get cheap wins that also, are stack modernity wins, we should do them. But this is a stack agility first and stack modernity second idea. I heard one thing that I wanted to pick on, though. So you said that you did some testing with people using the API, and they were scared of not having a stream. Is that feedback to the TAPS working group, or is that, should we consider that?
I don't think so.
Okay.
This is not actually feedback that we received from people adopting the API.
Okay.
It was mainly from like other people reviewing the API.
Okay,
And I think they were concerned that a lack of a stream would put some people off. But I think the time frame that we're working on here and the documents to back things up actually justify not really focusing on that.
Got it. Cool.
So we're out of time. Please be quick.
Mayor Kulevin, are you supporting multipath and are you exposing any of that to the application?
Yes. Yes. So this these connections do support multipath. It is exposed as one of our few top level protocol specific parameters. There's a multipath service type in which you say you want no multipath, you want handover style multipath, or you want more interactive or bandwidth aggregating multipath.
Given there might be multipath quick at some point, it would actually be nice to have a transport independent interface.
No,
Right?
sorry.
Okay.
It's a top level thing, so it doesn't imply MPTCP.
Okay.
It is a multipath class.
Phil Teasdale, are you supporting framers or have you a plan how to support them?
Currently, no. That is something we want to add.
Thank you.
Hello, Tom Jones. So it came up at the interim that it would be good to start working on policy within TAPS. And in the NEAT project, we did quite a lot of work on policy as the magic part of our system. And so it came up that maybe we should talk about it in the working group so we can get a basis for the work that we did. Just to refresh everyone's memories, NEAT was an EU project that aimed to build a single API to internet transport that supported single-sided deployment. We built a callback-driven system. We had a policy system, which I'm just going to try and flesh out here. We supported multi-streaming, multipath, and pluggable security. Our terms are different than from the TAPS terms, and sort of all of this is from contemporary with the early TAPS work and definitely before the set TAPS documents we're doing. And so we talk about application requirements, the application signal down to the stack for the things they need. And then we work through transport protocols to try, and this is one of the core parts of the end result. And then we deal with paths, and a lot of the way we dealt with paths was storing stuff per interface, and we also worked them out through a source address and a destination address. And then finally, the result of our policy system is a list of candidates that are tried by another part of the system. And so I talked about this quite a lot. And early on, it was fun to talk about the NEAT API because we could say, NEAT is going to give you selection, and it would be really straightforward. The application will say, give me a reliable transport with low latency, and you will just get it, and it will be magic. And so we built an API that would enable that. And so the interface of the application was setting up the properties it needed, the things it required, and then we had a logic layer, and then we worked through a policy system that would work through this and give you what you requested and the best thing that you requested from the available set. And obviously this didn't work. There's a lot of complexity in here, and so even the simple question, give me a reliable transport on a low latency path turns into give me an acceptable reliable transport on a low latency path. And actually, I want the latency to be less than 5 milliseconds. And I have some other conditions. So I want a small amount of network buffering, and it needs to be high capacity. And we can just force our way through this list, and we can go on and on and on until we get to a really fine-grained point. And really, a comprehensive method for this is just too hard to consider for standardization. There's too many pieces to this problem. Okay, and so our policy system. As in the last slide, the interface we designed was very simple for applications. Applications say what they need, and then they fire off the NEAT system. And the NEAT system had a user API, which was this interface, and then a set of logic for building up the inputs into the policy manager, which implements the policy system. And then the policy manager would return a set of candidates that the logic in the NEAT system would try. And this is where we're calling TAPS racing happens, what we call transport selection. This is where we actually figure out what is going to work. And then once we have what's going to work, we can choose the best one. So the policy manager is made of a couple of pieces. We had a flexible rules engine, which allowed us to compare properties from the applications in like fuzzy terms, and because our interface was JSON, things could be misspelled and we would still match on these, and we could figure out if things were numeric fields. And then that information is compared against two databases that we maintain as part of the policy manager. So we had a policy information base, which is sort of static information, and a collective system for higher level policies, and a characteristics information base, which is information that we discover at our local network from connections which have succeeded, from connections which have failed. And so we can build up a historical database of what is probably going to work. These information bases store, mostly per interface, but we did have a second level object for this, information on transport protocols, latency, message size, the whole set of all the properties you could want to compare against. And actually a very good source of information would have been in the early PVD drafts. They tried to codify some of these transport properties. And when we implemented PVD integration, we just pulled these properties in. And we had a very nice mapping between the two. Okay, so the application sets up the request and it gets sent to the policy manager. And we had the ability to codify high-level properties, high-level policy requirements. Terminology is very hard for this. So an application could say it wanted low latency, and the first step for the policy manager would be to expand what we meant by low latency into a concrete set of properties. And alongside that high-level policy, the application could also indicate some more specific stuff. And so we use this to cull down the set, which was in the predefined larger request. The policy manager would then evaluate the information in the SIB, and we would generate a set of policy candidates. And then we rank the candidates on some values of best. We had a very confusing precedence score that either 1 was the best or 2 was the best, and they went up or down on it. I can't remember. And then finally, this candidate list result is fed into the racing and selection system. And so the important thing from this slide is that the API into the policy system comes from 3 directions. It's the application requesting things. It is the logic layer which implements the transport, dealing with this and performing more concrete tasks. And then finally, off to the right, we have an external system. And the external system allowed us to integrate into REST-based endpoints. And through this external interface, we were able to do dynamic provisioning for SDN. And this external interface is how we pulled in PVD stuff. And this is really powerful part of the architecture we did. So the project has concluded, and so we can actually have some solid lessons learned. The SIB is actually a really powerful part of this problem. And it's really useful to build up a database of information. And it's also an absolute nightmare. Things change, interfaces come and go. Our paths will change in the network. SCTP not working to an endpoint now doesn't mean it doesn't work in the future. And we have to figure out what's going to work. And we have to continually review this. And solutions here just depend on the context. So being in an SDN environment gives you a very different network perspective than being in a mobile environment. And then some stuff for TAPS. I think we need to capture the basic features of a policy system into our documents, but it's really too difficult to have a big, mapping of all features together. And I don't want to fill out our document with this because just nobody will read it. And the high-level piece is actually something we can do. We managed to have 5 high-level policies that were in a system, and I think by the end of going through some implementation experience, we will have a set of what is high level and applications really want. And if the architecture is right, then we can augment this over time. That's me.
Okay. We got 2 minutes for questions. Any questions?
Tommy Polly. So a lot of this you were speaking in relatively past tense. I guess kind of like the question that Aaron had earlier of like, hey, are we going to incorporate some of the TAPS stuff? What's the future path for this implementation, like because it already has a lot of the right building blocks, is it going to also start being a place where we can incorporate these ideas and test them in a different implementation?
I mean, it's open source. It's all there. Somebody would have to have
somebody
would have to have the right incentives to work on this, and it's not me.
Okay.
Thank you for your honesty. It's done. Yes.
Okay, just one more questions. Thank you, Tom. Teresa, so Kyle, you're gonna do notes. Kyle, you're gonna do notes for this? Yeah, thank you. Try again.
Yeah, no. Okay. Hello, I'm Theresa Enghardt, and I'm going to talk about the policy system of the socket intents prototype, which is joint work with Philip. Now, the focus of the socket intents prototype, it's a research project, and we are aiming to optimize application performance on the host. So the scenario is multiple permissible paths are available to the host, and we want to figure out which of them we actually like better, or which of them will actually help us optimize application performance. And now we do this by basically selecting one of multiple available local network interfaces. And for this, in our policy, we do a lot of heuristics, like we estimate download time over different interfaces, and that sort of gives us an idea of which of these interfaces works best. So if we talk about the policy and socket intents, it is basically an implemented decision logic that gets several inputs, such as the available local network interfaces and some characteristics for them. I'm going to go into detail about that in some next slides. And then from the application, there is a request to open a new connection, for example, so some sort of request to communicate. And the application also gives us the socket intents. And these are inputs to the decision logic, the policy, and then the policy can rank, in TAPS we call it ranking paths, and in socket intents we call it, well, it selects the better of multiple interfaces, and then it can also do some more things. So first about the inputs in a little more detail. Socket intents are additional pieces of information that tell us what to optimize for. So the application tells us on some higher level what it wants, prefers, or expects, and we have already talked a little about like these more high-level inputs from the application. So for example, avoiding a costly interface, which could be a better way to abstractly say, I don't want to use LTE like right now, because maybe who knows in the future what other types of interfaces we're going to have, or like what is going to be the behavior. So we are opting for a more abstract way here to specify such properties. And then also, for example, properties of the traffic. Hey, I want to send a big file, and how big is big? Well, it's going to be like an update for my operating system. So it's 100 megabyte. I already know that. And then the socket intents policy can use this as input to the decision. And then the other part that the policy gets as input are characteristics of the path, which we mostly abstract per interface. And basically in our prototype, we gather some characteristics periodically by observing the local traffic and then aggregate them, which would be a similar thing possibly as some like characteristics information base, which we have in the implementation draft, and like sort of parallel to, yeah, but we don't store the exact same type of information, but we do store some metrics of the paths. And there's more details about this in the paper and a poster that I submitted to, that we submit to ANRW, and there's like, the poster is still downstairs if anybody is interested in the details. And yeah, here we reason a little about like how do we actually get those like per interface RTT values or bandwidth values, or what is the current utilization, which again helps us optimize. And then the policy gets both the socket intents and those, when it gets the socket intents and this path characteristics, and then the application wants to, for example, open a new connection, the policy can select a path via choosing the local network interface. It can also, as it resolves a name to an IP address, and maybe it gets different IP addresses, it can order them, so it can like sort of impose a preference for a specific endpoint, and then it can also set a socket option on the socket. And what we also have, what I'm going to talk a bit more on the next slide, is the policy can know about, oh, there is already a connection open, and it is not being in use right now, so I can reuse a connection, which is what we need for a per message path selection. So, for example, there are multiple requests being sent from the application, and like it wants to get a response to each of these requests, and then we can choose the suitable interface not only for the entire connection, for example, for a TCP connection, but we can also distribute different HTTP requests onto different network interfaces, for example. And so implementing this is not trivial for a stream-based transport protocol such as TCP. What we do is we have a pool of open connections, basically open sockets, and there can be like some TCP connections over the Wi-Fi, some over the LTE, and then the application just says, hey, I want a file transfer of 100 megabyte, and then we give the application back one of those sockets, and it could be the socket over Wi-Fi or the socket over LTE. The application at this point doesn't have to know, and then it can just use the socket and then say, okay, now I'm releasing the socket back into the connection pool, and this is how we like do this type of selection. Now, yeah, there's this the general question, like how do we assign a message to a path? If we had a multi-streaming protocol, that would be easier because at some point we are running out of TCP connections. We have to open new ones, which the policy also factors in. But yeah, multipath PRIC, for example, would be really great. In a prototype, we actually also play a little with multipath TCP path managers. But yeah, we think that selecting a path like for individual messages could also be an interesting thing. And yeah, as some words about the implementation, the socket intents prototype is on GitHub under this URL, so people can play around with it. It's still being developed. And the multi-access manager is another component that is like not the API, but it's a daemon running on the host. And this is the part that collects the path characteristics, and it loads the policy as a module. So again, the policy is kind of a implemented decision logic that gets some input and has some output, and it can also be exchanged at runtime. Now, in the future, we want to explore more like these possible performance benefits and which intents do actually give us the best performance and how much. And then also another idea that we have is to formalize these socket intents policies more, because now they are kind of like heuristics, but we could also formalize them a little more to like maybe be able to reason about them differently using a domain-specific language. And you can read a little more details in our draft, which you can see on slides. And yeah, I think that's it for this presentation. Questions?
Kyle Rose, Akamai. I have an implementation question about the stream socket reuse. If you go back 2 slides, is that this seems to be implying something about the underlying about the application layer protocol, right? So like this works with HTTP because it's stateless, right? It doesn't, the socket needs to be in a good state, et cetera. What are there, like settings or whatnot in there that tell you whether the pool can be reused? And
Well, we have in the API, we basically have a knob that, or we have a parameter we get back that tells us whether this is a new socket or whether we have seen this socket before. And so we know whether we have to like set up a new state on the socket, for example, encryption.
So this is not necessarily reusing a connection. It could just be you open a bunch of connections in advance to make sure they're there.
Right now, we basically open a new connection if we don't have one that we like enough, or otherwise, after we have used one connection and it goes back to the pool because it's been freed, then we can reuse this connection. So we don't like open many of them
assuming
before.
the state of the connection can be reset or it's stateless.
I'm sorry, what?
Assuming the state of the connection can be reset or that it's stateless.
Exactly.
Okay.
So that is kind of specific to stateless protocol.
Hi, Jared, from the floor. Yes, I was waiting because we have this experiment. This is kind of like what you guys are implementing, and you're talking about policy. And I was hoping that somebody will talk about a policy that also have something called network policy in it. So what that means, like we heard about like system policy. Tommy was talking about system policy parameters, and then you also have some policies that it's actually a system level or application want to talk with your TAPS services. But there's also called network policy, because nowadays the applications are getting settings from the network saying like on a particular network, you might want to stick to this path. Say you said like LT, so like on LT network, you might have something called zero rating. Zero rating, that means you don't want to change because it doesn't really matter, because you talk about cost, like costly path or costly interface. So I was hoping some of you guys will be coming here and saying like, yeah, we also consider network policy as an input to our policy manager or something. So what you guys are thinking? It's not, this question is not particular to you, but anybody can answer.
I'm sorry, just to clarify, you mean that the network has a say in which interface I use, right? Because this is purely host-based.
Well, network don't have this, it has input to it. So, for example, say on a LT network, you're on a LT network, you find a new interface called Wi-Fi. And obviously, usually you'd say like LT is the costliest, switch over to Wi-Fi. But the LT network operator could actually have an agreement with the application saying like, as long as you're on my network, I don't cut your data bucket. So in this case, you'd like to have LT connection because that's more reliable than Wi-Fi, right?
I see.
Sorry, Tom Jones just responding. We model this in Neat with the information you get from PVD. PVD will tell you price per megabyte. And so we can use that as a selection criteria to figure out if this is the right network to use. And the PVD information carries if this is Wi-Fi or LTE. So these could be inferred properties from that.
We also get some information from the Wi-Fi access point about the current channel utilization, like percentage.
Yeah, sure.
So
I mean,
that's not exactly the same thing, but we also get something.
Yeah, that's true. I mean, you can do all these things. I mean, I'm just hoping like you have more explicitly have some information, because PVD you have a data bucket kind of information, but that's for your interface, not for particular application. You might actually have a same like a connection that has a different behavior for different applications.
So we're over time. So it's an interesting point, but I don't think we're going to necessarily resolve it right here. Okay.
We should wrap
well,
up,
then we'll at least take Tommy and Brian's question, and maybe we can revisit this if we got some time left. There is no meeting after this. I don't know when things leave for the social, but last session.
All right, Tommy, Polly. So thank you for sharing this. Just one high-level comment. This actually reminds me a lot of some of the layers that at least on our system build on top of us, which are handling kind of the HTTP loading and stuff. The fact that you have a pool of connections, the fact that you're determining which is the best to use between them. So in a lot of ways, I see this as potentially a layer on top of some of the stuff we're specifying here in TAPS. I think as I've expressed previously, some of the vagueness of what the intents may mean, especially if I need to know, oh, this is the number of bytes I have a priori. What happens when that does not line up with exactly with what we're going to have? I think that is appropriate at a higher level. How that translates down into a lower level is less clear. One thing that I was thinking of, though, because you're mentioning, hey, multipath quick would be great. And I think when we look at things like multipath quick or even just migratable quick and MPTCP, things that can dynamically change what interface they're using, that's an opportunity for the TAPS layer not to rely on an intent of saying, I'm about to send a lot of megabytes, but to actually react to a real send, such that maybe some higher level, like what you're talking about here, determines the initial configuration to use. But once you actually schedule a send of 100 megabytes, that's a great opportunity for a migratable connection using MPTCP or Quick to actually react and use the same logic that you're talking about here about which is the best interface to select to do it dynamically. So I'd like to challenge you when we're applying some of these things to TAPS, what are the ways in which this same logic can be done automatically based on the information already being communicated by what the application committed to in the send?
Okay, thank you.
Hi, Brian Dremel. Seconding Tommy actually on a lot of the stuff that he said, which is one of the reasons I came in after him. I think one of the things that we need to do in the TAPS interface document is to make sure that systems like intents can ride on top of them, right? Like so that you can take these higher level goals without reaching all the way into the connection selection logic and changing sort of the rules of that. I'm not sure how to do that. I think this might be the experimental RFC that Zahed wants us to produce. With a different hat on, I would encourage you to take the interface and path measurement stuff. And I know you've already given a presentation to PanRG. I'd like you to bring that to PanRG, like to distill it down a little bit. So this this path characteristics per interface, we'll have to fix that. But this is like sort of the first question that we have in PanRG, I think would be answered by some of the research you've already done. So yeah, I know you'll be there on Friday, but I think I would encourage you, if that question is going to come up, and I would encourage you to stand up and say, oh, we've already thought about that. So thanks.
Thanks.
Thanks. Thank you, Teresa. So did Chris make it? Guess it's you. Last week.
Last but not least.
So, oh, yes.
All right, so we're going to, I'm going to give an update of the security survey. This document has undergone a bunch of evolutions since London. The updates include improving protocol justification text and sorting protocols based on use and impact. So there was some feedback at the end of the London session about, I think concern basically that we were either including too much stuff that was not, maybe not appropriate or maybe not widely enough used to be relevant. And also to make sure that we came up with some consistent standard for deciding which protocols to include. We also spent a bunch of time canonicalizing the security feature set so that we would have some consistency between the protocols that were listed in the draft. Before, it was kind of, it was very ad hoc. It almost seemed like some text was copied and pasted from different places and not standardized in some way that would allow someone to understand exactly why we chose one thing and not another. And we also did a bunch of interface cleanup, where by interface I mean the way the security protocols interface with the transport protocols and other layers of the stack. So this is just an example of some of the security features that we listed in the doc. There's a much more exhaustive list of them in the doc. I encourage you to take a look at it. I'm not going to read through all of these. We did come out with 5 mandatory features for any TAPS protocol that requires security. And these are segment or datagram encryption and authentication, seems obvious for a security protocol. Forward secure key establishment. This seems to be the standard now, so we're not going to accept anything less secure than that. We're going to want public key, raw or certificate-based authentication. So we need some way to authenticate endpoints, and so that'll feed into some of the protocol security protocol selection later on in the doc. We need responder authentication, which is what was Tommy? Do you remember what exactly that means? It's a term of art. I'll look it up and mention it later, but it's something I just forgot. And then pre-shared key support. Miria?
Yeah, I'm already confused. I mean, there are a couple of protocols which support encryption without authentication or authentication
TCP crypt.
without encryption, yes. Those are excluded?
No, but if somebody, so for instance, one of the, I'll get into this a little bit later in the presentation, but we have in the list of optional features, there's essentially application level delegation of authentication. Right, and this is what TCP crypt does, right? It doesn't do authentication, but it provides you with a channel binding upon which you can do authentication at the application layer. And so in most cases, you're going to want to do some kind of authentication, but whether you need to do it at the security protocol layer or at a layer above is something that's up to the application. Does that make sense? We're just providing a little bit of flexibility. Or maybe I will take more than 10 minutes.
Sorry. What about authentication without encryption? That's harder, isn't it?
Sorry?
Like TCP, what's it called? OA?
Yeah, that's out of scope for this.
Okay.
So this is the matrix that I was talking about. So this is essentially a table of optional features and showing whether, for each protocol, whether that feature is supported, mandatory, or unsupported. And so you can use this table by looking through looking at the columns of the feature that you want, finding which ones are either supported or mandatory and which are unsupported, and then essentially taking the intersection of the two. So in this case, systems wanting to provide algorithm negotiation, meaning some sort of algorithmic agility, and mutual authentication can support the protocols listed in blue, because that's the intersection of supported or required on both columns. Similarly, for this example, systems which must provide connection mobility and session casting management should only implement the protocols in blue. So it's pretty straightforward. So we got some informal feedback last time to remove protocol details that do not affect features or interfaces. So there was a lot of text in the draft about features of the different security protocols that were not relevant to the choice to include or not include the protocol in the draft. And we removed most of that because there are normative references for understanding the protocols themselves. We just put in a very basic summation of the stuff that was relevant to TAPS. We also found that trying to generalize security interfaces for all protocols is hard. Right? It's not an easy problem, and we spent a lot of time trying to come up with a set of features that sort of made sense across the wide spectrum of security protocols that we were surveying. So generic and protocol-specific interfaces must be provided, right? We need some way of separating out the security features that are relatively generic across protocols, and then the security features that are specific to an individual protocol. So there are some things that you're going to want to be able to configure for any security protocol that might be appropriate for your communication. But then if you happen to choose a specific protocol, if the TAP system happens to choose a specific protocol, you may want to sort of tweak the parameters of the specific security protocol that was chosen. And so we have to provide some way of doing this. Finally, going back to the earlier discussion where I said that I was going to be forced to support something that I was not entirely in agreement with, this is that slide. So this is saying that protocol equivalence must be based on name, not feature availability. And I'm going to sort of argue that there are two ways of looking at this, and one is, yeah, we're not really chartered to do in-depth security analysis to understand whether protocols are exactly equivalent or not. But on the other hand, if you're requiring, let's say you're doing a race between multiple protocols and you're requiring that the security protocol in the stack for each of those be exactly the same, you're going to end up with less agility in the protocols that you're able to race between, right? If you can't consider TLS and TCP crypt with application level authentication to be mostly equivalent or to meet some minimum standard that is appropriate for your application, you're not going to be able to race multiple things. You're basically going to imply a single protocol just by your configuration. And I think we want to avoid that. I don't think that was the intent either. So I think we need to clarify this and come up with an actual set of criteria that will allow us to say race, if we were going to cover GQuick, race GQuick against, HTTPS.
Jonathan Lennox, I agree that, security protocol equivalence or whatever is probably way too hard for a V1 spec, but I could certainly see something like an application saying, okay, any of, GQuick or TLS or DTLS are accessible for my purposes, and I'm just giving you a list of everything that's acceptable, and all those could be raced.
Right, and that's one of the things that I was thinking would resolve this. So,
The one we're going to want to support is HTTP2 and TLS over TCP and HTTP2 over QUIC, which should be counted as equivalent, but then they're different.
Right. Well, it's not. So H2 over QUIC might not be the right way to phrase it.
Yeah, but the
like the H2 layer that is part of QUIC. Yeah.
Right. But the way they do the security is different, but they should be comparable if they're both dropping down to TLS 1.3 equivalents.
Right. But it could, as I said before, right, conceptually, theoretically, there could be some side channel that's exposed in one and not in the other just because of the way they do framing or something like that, right? And I'm not sure that that's the level of control we need to provide the application. I think that's getting way too far into the details. So anyway, so next steps are to formally circulate the draft to the security area, find out what they have to say about this. And then finally, getting back to the point that Aaron made in London, maybe consider relocating some of the more obscure protocols into an appendix or into some other section. Questions? I added the shadow.
Nancy.
It was the first time I was playing with Keynote, so.
I was wondering whether it makes sense to move this security protocol equivalence to some higher layer like we discussed with some of the other properties before. So having a higher layer that's specific, I want a decent set of security protocols and saying, okay, that's out of scope for TAPS. Here we want to have the list of the ones that are reliable by name, but perhaps moving this to a high layer?
Yeah, so I think, there are two sides to this. So the first is, I'm not going to specify anybody specifically, but channeling some of the people in the security area, you'll get the argument that that's a good idea, partly because there is a minimum bar for security below which you must not go, and then anything above that is kind of like icing on the cake and is sort of irrelevant. Like you don't want to go below like AES 128, right, or something like that. The other side of that, though, is that individual security protocols have their own little quirks that may make them more or less appropriate for certain use cases. And so it's not clear that it may be that it really does matter what the application is doing as to whether a particular protocol is appropriate or not.
It seems to me that Tommy's proposal for generic properties and specific properties that you put up earlier could be sort of bent in such a way that it would allow us to sort of, have both kinds of equivalence class.
Well, just make sure that,
Yeah,
the
right.
padding option
Yep,
that
yep,
you
yep, yep,
add
yep,
for
yep, yep.
TLS
Yeah, yeah,
is,
yeah.
and like some new protocol comes along and you meant to have a padding option associated
Yeah.
with that, but it was a protocol specific option.
Wait, no. So specifically, I actually want to take the concept and bend it a little bit so that you actually do, like, you would have essentially a selection scope in which naming is how you do it, and then there's a selection scope in which equivalence class, where you basically have sort of this security area equivalence class where it's like everything that is at least good enough to not get you yelled at in SAG goes into an equivalence class. Right?
That is going to expand over time, right?
That's,
And
yeah, of course.
and
Yeah.
So
Right.
whatever framework we come up with has to make
will-
sure that it works
yeah.
with applications that are written today and don't
Yes.
know about those.
Right. It will expand over time, and then occasionally in fits and starts over time, things will get shed. Right. This is how we do it right now. Right. Like, so 20 years ago, we thought TLS 1.0 was fine.
Yeah, you no longer have to specify export no.
Right. Exactly. Yeah. So exactly. But I mean, like, so the set of things that go into that sort of that big, I don't care class. That's the security area's job to do. And I actually already publish recommendations there, and we can just follow them, right? So.
Okay. Any other questions?
Tommy, I have a question for the chairs about what do we want to do with the schedule for this document based on the milestones. I think some of the stuff we're talking about here about equivalence, that's actually not this document, right? That's the architecture and other stuff. This is just the survey. I think the main thing that we need to do is get the formal feedback, because we've talked to Ecker and other people about this, but we need like their formal review. What do you see as the next steps here?
I think the formal, we will learn a lot in the formal review about how much more work is required. Modulo that, are we sort of in the fine-tuning stage? Is this, if they came back with a null response, would you say this document's ready for working group last call now?
We definitely done everything.
By the
It
time
needs a
they
little
get
bit of
back,
work, yeah.
by the time they get back to us, I think it would be.
Yeah.
I think it's close.
Okay. So I think maybe that's what we should do. We should take it to Sec Dispatch or whatever the appropriate way is to get their review on it, and continue to work in parallel on the fine tuning that you want to do.
Too bad those meetings didn't occur in the other order.
We didn't know we were ready yet. I mean, it doesn't happen. The review's not going to happen in the meeting. A question I have is, let's see. Do you and Chris feel like you can take it to Sec Dispatch? That do you want the chairs to be involved in that? It seems I don't see that it's.
I think we can
adds
do it.
value.
Yeah, I think it's fine.
Sullivan, as
Yeah,
a
there's so many
chair, you
ways.
can just click a button and request a SecD review.
Really? Can you
Yeah.
show me what the button is?
So
Let me
Anders-
Google that for you.
Yeah. That won't help.
Anna
Sorry.
Lundström, I had a question now on this. Is it just the survey, or this should also kind of incorporate the MinSet part of things? Or
Sorry, I don't understand. What do you mean?
so for the protocol side, we had the survey phase, right, and then the MinSet step, so that the analysis was kind of in two steps. And I was not sure for the security protocol side if this is supposed to cover both of those steps, or
That's
are we having?
an interesting framing. I didn't think about it that way. We're talking about the next question, right? I mean, yeah. Well, what we basically tried to do was take a candidate set of protocols and then sort of distill out what the common properties were, and or properties that were commonly found in protocols, and then choose the ones. I think to some extent we were relying on our experience with the security area to know which were the minimum set of things that were required for a security protocol. So maybe that was implicit. So I'm not entirely sure how to answer your question.
But so in some sense, the equivalence class could be also I mean, in some sense, it's in your tables, right? I mean, like what you were showing.
Right. Well, there's interesting features somebody might want to use, but are not mandatory or not kind of at the low bar for what is required when you call something secure. Right. I mean, we're not going to support like ROT 13, even if somebody really wants that.
So your 10-minute slide is at 20 minutes now, and you have one more question. So could we give Michael the last question and then wrap things up? Michael, you're on the air.
This is not really a question. I'm just trying to answer, actually. I think, having read the document, I think this is a MinSet type document. I mean, it's pretty similar in style in what I try to do in the MinSet document. And I don't know if we could say it skips the survey step. It probably doesn't. It's probably rolling both into one. But I think you can say this is a MinSet type thing. I mean, it's trying to do the same thing in the same style.
Do either of you have recommendations on how to improve the document? I would be interested in hearing that. I'm sure all of us would. So. Well,
I mean,
you don't have to answer it now, right? I mean, you could send email too.
Sorry, I wrote some in my comments to the list, and I was happy with your response to that, and how you addressed them.
Okay.
Thank you, Michael. Just to confirm, do you want to rev the document again now before we send it for security review?
Almost certainly.
Okay, great. So send a note to the list when that's ready, and then now I know where the button is, and I'll click it.
All right, sounds good. Thanks.
All right, thanks everybody. See you in Bangkok. Oh, we're going to schedule a virtual interim, probably in September, since that's about halfway between there. When is Trammell 2.1 expected to be deployed? Okay, so September would work for that? Yeah, we'll do it. I just wanted to at least know the month. Cool. All right, another successful meeting. There should be another clipboard. The other blue sheet somewhere? Anybody see where the other blue sheets are? Thank you. I